Hello everyone, welcome back to this another video. And of course, as usual, I do trust and hope that we are all staying safe and is doing well. We're going to continue having fun with math and of course, you know, exploring some concept of math. And what we want to look at today, what we want to start exploring together is that concept of normal distribution as we continue to collect data for purpose of research, for purpose of information, and the world in which we live to aid decision making, to analyze information and use it to predict possible outcomes. It is very important for us to understand different data set, different distribution, and how to determine as we go about collect data the type of data set that we're collecting. And so we want to discuss today the concept, the principle of normal distribution. Now, what we want to take away today from this video is how can you determine if the data you have collected is following a normal distribution or even close to that of a normal distribution. We want to be able to explain a little more, the concept of normal distribution, how we work with normalized data in our day-to-day situation, how we can use normal distribution to make prediction, and just why is the knowledge of normal distribution so important, especially as we go on to collecting data, and how this question can help us in solving problems. Now, let us look at a very simple scenario here. We want to look at a very simple scenario. Um, the table shows the percentage test score of 100 students in a math test, right? And we're going to complete this table together. So here we have scores ranging from 50 to 95. Let us say 3% scored 50% on this math test. Let us say 10% scored 55%. Let us say 12% scored 60%. Let us say 15% scored 65%. Let us say 20% scored 70%. Let us see another 15 students scored 75%. Let us say 12 students scored 85%. Let us say 10 students scored 90%. And let us say 3 students scored 95%. So here we have a total of 100 students who would have done a math test, and this is the scores. These are the scores, the percentage scores, and of course the total number of students who sit the test was 100. Right? Now, this is what we want to look at today. We want to calculate the mean, the mode, the median, and the standard deviation of the data set that we have. We also want to explain or determine if the data is normally distributed and why. Why can we say the data is normally distributed? When we're analyzing data, what can we use to determine that this data is normally distributed? Three, if the data is normally distributed, we want to sketch the normal distribution curve. And then, of course, we want to use this curve to just make some simple analysis in our discussions and show you how we can use, when we have a normalized data set, how we can use this to make simple predictions. Now, we want to start by finding, let us start by finding the mode, the modal score. Let us start by finding the modal score. And we know the modal score is going to be that score where most students would have scored on the out of the data set, and that's going to be 70. So we're going to write that here. Then we want to talk about the median score. Just talk about the median score. Now, in order for us to find the median score, we first need to locate what we call the median position. And we can do that by using the formula n plus 1 divided by 2, where n is our total frequency. So that's going to be 101 divided by 2, which of course is going to give us 50.5. And then we can locate by adding our total frequency. So we're going to say 3 plus 10, that's 13. 13 plus 12, that's 25. 25 plus 15, that's going to give us what? 25 plus 15. So that's going to be 25, 35, 40. When we add 20 to that, we're going to get 60. Right? So from 40 to 60, we know our median position is going to fall in between here. And so our median score is going to be 70. Now we want to find the mean score. Let us look at the mean score. Right, and we can just remind ourselves to find the mean score is the sum of fx over the sum of f. Right? And so in order for us to find the sum of fx, we need to multiply our frequency by our midpoint. All right, so we're going to start by saying 3 times 50, which is going to give us 150. Then we're going to say 10 times 55, that's 550. Forgive my writing. We're going to say 12. We're going to say 12 times 60. That's going to give me 720. 15 times 65. That's going to give me 975. 20 times 70 is going to give me 1400. Then I'm going to say 15 times 75. That's going to give me 1125. Then I'm going to say 12 times 84. That's 120. I'm going to say 10 times 90, which is going to give me 900. And 3 times 95 is going to give me 285. So to find the sum of fx, my frequency times my midpoint, I would have to add all of these values, which is going to give me, and I'm going to use my sigma notation here, and that's 6,975. Right? So now that I know what my sum of fx value will be, 6,975. I can divide that by my total frequency, which is going to give me 69.75. And we're just going to round this to the nearest whole number. That's 70. Right? Now, this is what I want you to notice. Let us look at and I'm going to just write it here. The modal score being 70%. The median score being 70%. And the mean score also being 70%. Notice all my measures of central tendency here are the same. And once you have a data set that is following this pattern, then we can say that our data is normally distributed. Our data is normally distributed. Right? And this is one of the things that normal distribution that we work with in everyday life. And you're going to see that a little bit more as we construct our normal distribution table. Now, in order for us to construct our normal distribution curve, we must be able to calculate, we must have our standard deviation. Right? And our standard deviation, just by way of reminder, is the sum of my median value subtract my mean value squared divided by my total frequency. And I'm going to call that n. Now, let us see if we can calculate our standard deviation. So here we have our first mean value 50. Our first value here being 50, midpoint value, and we're going to subtract the mean value from that. So we're going to subtract 70 from that to give us -20. And we're going to do it to all our median or midpoint value, here. So that this would give me -15 followed by -10, followed by -5, followed by 0, followed by 5, followed by 15, followed by 20, followed by 25. And I'm going to square all of these values here. So when I square this, I will get 400. 15 squared is going to give me 225. -15 squared, sorry, -10 squared is going to give me 100. -5 squared, that's 25. We know 0 squared is always 0. 5 squared is 25. 15 squared is 225. 20 squared is going to give me 400. And 25 squared is going to give me 625. Now my sum is going to be 2025. So here I can calculate my standard deviation, which is going to be the square root of 2025 divided by 100. And of course, this is going to give me 4.5. So thus far, we're able to use our mean or mode and our median to determine if our data follows a normal distribution. And what we're going to do now is we're going to sketch our normal distribution curve. Now, one of the things that we need to know, we need to understand about our normal distribution curve, very important, is our normal distribution curve is always centered around our mean score. And our mean score here is 70. Now, every other value on our normal distribution curve is going to tell us how many standard deviation are these scores away from our mean score, right? And so we're going to, our first value, our first standard deviation to this side of my curve is going to be 74.5 because we're adding the standard deviation value as we go along, followed by 79, followed by 73, so followed by 83.5. Now to this side of my score, so notice I am adding my standard deviation to this side of my curve. I'm going to be subtracting my standard deviation. So my first standard deviation away from my mean score would be 65.5. 65.5. Then I am going to have 61, followed by 56.5, followed by 52. Now, here we are. And of course, we want to sketch as much as possible, as much as we can, our our normal distribution curve. So here we're sketching our normal distribution curve. And so we're keeping the sketch flowing. Now, if you notice that whenever you sketch a normal distribution curve, you're going to get something shaping like a bell. We also call it a bell curve, right? Now, we know that if your data is normally distributed, this is where your mean, your mode, and your median value will be, all three values will be here. Now, because if we should go back to the data set, let us go back to the data set. Notice one standard deviation, both side of my mean score, Notice what happens to my data set here. And we're going to go back. So that's 65.5 to 74.5. Let's go back to our table. 65.5 would fall right here to 74.5 would fall somewhere here. Notice 15 plus 20 plus 15. This is where majority of my data set is going to be. And so we know that when we have a normalized distribution curve, majority of our data set is going to fall within the first standard deviation, both side of my mean score, right? Normally, we say one standard deviation to my right is going to be 34.1% of my data set. And one standard deviation from my mean to my left is going to also be 34.1% of my data set. So one standard deviation in both direction is where most of my data set is going to fall. And what are we saying by this? This is saying that of the 100 students, most students you're going to find them scoring anywhere from 65.5% to 74.5%. That is where most of the the data is going to be. And for all normalized distribution, right? What you find is majority, a large sum of your data set tend to be very close to that mean value that you have, right? Now, with these two standard deviation being where majority of our data will be, we're going to have another 13.6%, and that is in our second standard deviation, both left and right. Then I'm going to have 2.2%. And then I'm going to have 0.1%. So what you're going to realize is So you're an educator since we're working with test score. You're going to find very few people you have a data that is normally distributed with a mean score of 70. You're going to find very few people, very few people doing extremely great. You're going to find very few people doing extremely poor. But majority, and let us say the pass mark for this test, the pass or the pass score was 60%. Majority, what you're finding here is that majority of your students is scoring what we call an average. They are performing at an average rate, and that is why we say that this data, this is how we know, we can understand fully that this data is normally distributed. Now, it is very important to analyze your to be able to analyze your normal your data when it is normally distributed, and understand really how it is that we can use this data to 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 answer questions, to make predictions, you know, to calculate possible outcomes, right? And when we talk about possible outcomes, we're talking about probability, right? And we're going to get into that, of course, in another video. So by now, you should be able to, given any data set, to determine the using the mean mode median, if the data set is normally, to explain if the data set is normally distributed, using the mean and the standard deviation to sketch the normal distribution curve, and to make simple analysis using your normal distribution dataset. Always a pleasure. See you in our next video.